Right. Before I actually did applied math, this is one of the last things I worked on, and I was developing my career as a pure mathematician. There's a number of these papers that I'm showing you right here. If you're interested in this particular topic, we have one more paper that's a list of open problems in this area. So Steve Lettieri is one of the, if not, I think he was the best student I ever had as an undergrad research student. He was physics. We can forgive him for that. He got his PhD in physics, but he was very, very talented at pure mathematics. And so he did his, we didn't have a thesis, but he did his thesis with us. And then he went on to go to the national math meetings and win a national prize for his work. So, and we still talk and work together. He actually has published some applied math papers with me as well. So he's good at both of these. And there's another student that I had. I actually left off hers. She is a high school teacher now in New Jersey, but she also has published on this topic. So there are accessible pieces of this. That's what you should know, is there's pieces of this that you can actually take as an open problem. All right, so what is this? It's actually an old problem. It was posed for the case n equals 4 by an Italian mathematician with the last name Ducci, I think back in the 1800s. And people have published on this quite a bit after that. And so when we came on, there was a lot of different avenues that people have taken, but the main problem still remains open. So what you have is, you don't have a vector, you have a string of integers. It's not a vector because if you recall the definition of a vector space is that it had to satisfy those 7 criteria. Integers do not satisfy those 7 criteria. You can't multiply by a scalar and then remain, you have all issues with closure. So, so we call this a string of integers. You take a string of integers of length n, so I have z to the n, which means that every input in the components are an integer, and then you iterate it by taking x1 minus x2 and then the absolute value. So the next thing is going to be a positive integer, all of these guys. Until you get to the very last one, because you have xn and nothing to the right of xn, so you wrap it around and start back with x1. So you subtract from the beginning. So for example, if I have 1, 2, 3, 4, my next iterate would be 1, 1, 1, 3 by just applying that rule. Now, if you keep going, the question is, what happens if you keep going? So this is homework 13, part 1. You guys are pretty tired, so I'm going to ask you to take boards and iterate this on boards further. Take that 1, 1, 1, 3 and continue on. And save your work. Make it neat because you're going to take a picture of it.